Today, I'm going to talk about 10 things we've learned from running production infrastructure at Google over the past around about 20 years that we have been doing SRE at Google. Over the years, my brilliant colleagues came up with lots of phrases and proverbs or adapted others from other fields and areas of life. And I think these are great lessons and principles that really condense down key information, key learnings from running production systems in a software environment. So who am I? I've been at Google as an SRE since 2014. I'm currently based in Google's Munich office. I've worked in different areas in Google's ads business, in cloud, in our internal developer infrastructure. These are all very different environments with different needs. But for the past few years, I've been working on central SRE programs and tools for the organization. So basically, my teams are basically SRE for the SRE organizations, super meta. But before Google, I've been a sysadmin, I've been a developer, I've been a consultant. I did research on the reliable distributed systems. I did my PhD on that. I never thought it would be useful in the real world, but turns out there's a career in that. So that was kind of unplanned. But show of hands, who here knows what SRE is? Good part of the audience. That was very different. When I started interviewing for Google, I had no idea what I would be doing there. They explained it to me 3 times. I still didn't get it. Took me a few years. But Ben Trainer-Sloss, who started site reliability engineering back in 2003, his shorthand definition is SRE is what happens when you ask a software engineer to design and run operations. That just sounds like a fancy name for an ops role, but it's not an ops role. We'll talk a little bit more about that later. But really the key part here is the engineering. It's in the site reliability engineering, but it's also about software engineering in this definition. We're not all software engineers by trade. SREs come from many different backgrounds and educations. But what we do share is we can all read and write code to some extent, and we speak the same language as the developers, and we apply a software engineering mindset and methodology to operations, and which is very different. It's very different from running a shop, being a salesperson, and building a shop system. That is really kind of the analogy for SRE. Now, Google is a big and unique company, and you might ask, and rightfully so, why would any of the things that Google does apply to my organization, to my employer, to my role? And your environment, your organization is different. Every organization is unique. And please do not take anything that I say here as a blueprint that you copy-paste to your organization. Never do that with what anyone ever says. Apply it to your context, adapt it, tweak it, take it as inspiration, and discard all the things that do not apply to your environment. But then again, Google is not this one uniform, monolithic thing. There are many different organizations, business, product areas inside of Google with different areas. Some are enterprise-focused, others are consumer-focused. Some are very mature with billions of users. Some are very startup, like early, rapid development and lots of changes. And all of these have different needs. And the SRE practice has been adapted to all of these environments. So the fundamental principles are not very organization-specific. Hopefully, I distilled the principles that are useful to you. I have 10 areas of them where I group things together. And the first, I think, 4 principles are about culture. You engineers, some engineers care about culture, some engineers care about machines and don't want to be bothered with culture and organization and like all of this managerial stuff. But I see culture a little bit as an engineering problem. It's kind of like your development tool chain. So is the organization around you. If that doesn't work, you can't really do your job. It gets in the way of the engineering. And similarly, often when I hear people talk about they want to do SRE or whatever the latest fad is, they talk a lot about like we need to do these tools and we need to do this methodology, we need to have observability and this monitoring suite and we need to introduce SLOs and so on and so forth and they have specific tools and skills in mind. But what they forget is that, as they famously say, culture eats strategy for breakfast. So many of these like very ambitious initiatives just fizzle because the employees are not willing to follow. So understanding your culture and adapting a strategy to your culture and evolving your culture to better serve the business is really important. Now, let's get started. Number 1 is reliability can't be taken for granted. Sounds trivial, but it's a little bit like air, like food, like all the little things that are ubiquitous as long as you have them. So nobody really cares. And then when you run out of them, then it can take you a very long time to get back to the surface. If you get into a state where your production systems are inherently unreliable, there's not one thing that went wrong. There are many, many things that went wrong over a very long time. And often it's not sufficient to just fix this one thing. You have to fix like a lot of those to get back into the green zone. And while you're being busy doing that, you're not working on what you actually want to deliver to your users, new features, new products, and all of that. Well, guess who is? Your competition is. So you might be like losing 3 months, half a year, a whole year, and that can actually kill your business, kill your product. So you have to be prepared. And our official Google SRE motto is, hope is not a strategy. So you actually need a strategy for reliability. And that means there always needs to be a voice for reliability at the table in every stage of the development lifecycle. In smaller organizations, that can be just like all of the engineers. They understand that reliability, the non-functional requirements, as they say, is an important thing, and it's our responsibility. As much as user experience is, or security, and all of these things, it's not something that you shove to the side and say, oh yeah, we'll deal with user experience or security later. It's something that you think about all the time because it's part of the product, and so is reliability. So what's really important is to not start productionizing after you launch the product. You do this early on. And like when you make a wrong architecture decision, that's really, really easy to fix on the whiteboard. Just remove this box, move this arrow over here. But when you put quarters of development into it, you launched it, you have live user traffic on the system. It might be prohibitively expensive, risky, or even impossible to fix. So have the right conversation at the right time. Doesn't mean you should over-obsess about reliability, as much as you shouldn't over-obsess about any of these other topics, but make sure that you have these discussions, these conversations when they matter, without slowing you down. If you don't have them, you will be slowed down a lot, much later. So, number 2, cattle, not pets. This is a metaphor. This is not an endorsement for industrial and livestock farming. We're not talking about actual cattle, but in this metaphor, a cattle is uniform. A herd of cattle is like, you don't know them individually, they don't have names, they have numbers. If one of them gets sick, you replace it. Whereas a pet not only has a name, it has a personality. It's very, very unique. We love them, we don't want to lose them, and we put a lot of effort into them. Pets are high maintenance. So if you know the host name or the IP address of your mail server, it's a pet. It's not cattle. If you know the host name or the IP address or like the quirky bit in the configuration of any of the servers that you have, it's a pet. And a lot of companies have a zoo of pets, and that is not scalable. It's not scalable because every change needs to be specialized for each of these pets. Can't roll it out at scale. It makes automation very hard. It's fragile. Like, you apply the same update to 100 servers, 5 of them break, each for their own unique reason, because they had a random flag set or some package not installed, whatever. Different version. And that standardization can happen at many levels. It can be the hardware, have the same boxes, not special configured hardware. It can be the infrastructure, say, you use the same operating system, the same version of the operating system. Or it can also be on the architectural level that you decide you pick this kind of database, this kind of communication patterns, this kind of like style guide for your code. And this is not only about the reliability or the cost. This is about the scalability of the people as well. Because there's only so much that an individual engineer can keep in their head. And if you are on call for 10 different services, each with their own deployment pipelines, each with their own monitoring system, each with their own very involved architecture, you have a problem. Whereas if you're on call for 10 different services that all look the same, they also use the same CI/CD infrastructure, the same approach to it, the same monitoring, and so on, it gets a lot easier, and that frees up space in your brain for actually interesting and relevant things. Number 3, blamelessness. I think that's a widely known topic. Finger pointing is not helpful. Things go wrong. You should always assume that everyone in your organization, in your team, is competent and well-intentioned. Because if they are not, you have a much bigger problem that finger pointing will not be fixing. And the thing is that if there's this big red button that takes down the system and Christof pressed it, the question is not, why is Christof so stupid? You can't fix that. Many people have tried. The question is, why did we have this button in the first place? And why didn't have any kind of guardrails or protection? And why didn't Christof have any instructions on, like, this is what this button does? Can we remove it? And this is what the conversation should be about. How can we prevent recurrence when we don't assume that the people magically got smarter? And the important part about blamelessness here is that everybody must feel comfortable bringing these things up. Whenever something goes wrong, people must be willing to say, hey, I just broke the system. And this is what I did. How can we prevent this from happening again? And if people have fear that they might have consequences, might get yelled at, or even lose their job or something, they won't do it. These things get swept under the rug, and they accumulate, and you get bigger and bigger problems instead of improving your systems. Number 4, measure what matters. Obviously, service level objectives, SLOs, that's a big thing. You have measurable goals. They are objective. The ops team, the dev team, product, everybody agrees, these are the things that our business needs, that our users need, not less, not more. You get sign-off from all relevant stakeholders, and then if there is a breakage in the system, the conversation is not, is this bad, is this good, and there are different opinions. You just look at the SLO dashboard, is it green, is it red? If it's green, nobody cares, go back to developing features. If it's red, all hands on deck, we got to fix this. We have to improve the reliability of the system, and any other kind of development is not a priority at the moment. And the important thing here when designing these kinds of SLOs or other measures is to focus on the user. It doesn't matter if you say my system is able to process 20 megabytes per second or whatever, if that is not actually measuring what matters to your users. A user might be interested in my request gets handled in less than 10 seconds. And these are the things that you should build your SLOs around, and these are the things that you should measure. Because otherwise you might improve metrics that don't actually have an impact on the user experience, and you waste a lot of effort doing that. And also, you might be missing things that are actually impacting the users, and things that you don't measure typically get worse over time. However, whatever you measure, the idea here is only to get a better understanding. It's not that SRE or ops or DevOps or whatever your role is called and whatever flavor you are doing is a gatekeeper. It says this could be a risk, this could break something, stop here, I won't let you through. That is very confrontational, it's not helpful. You need to understand the reasons why the business, why the developers want to do things, and try to help them do the right thing in the situation, make them aware of risks, help them actively manage them, and not be the person that just says no, because then the other people at the company will stop talking to you and will find ways around you. So much about culture. Now operations. Operations is being on call for the systems, handling tickets, all these kind of things, is typically part of an SRE role. However, it is not the purpose of being SRE. The purpose is not that SRE keeps the system up with their sweat, blood, and tears. It is the idea that SRE learns more about the systems and the operations so they can improve it, but the actual value that SRE provides is through engineering, aka sustained value that outlasts the direct engagement of the SREs with that system. Number 5, the best way to learn how a system works is by watching it go up in flames with live user traffic. And it is something that you have to experience yourself. It's not something that you can read up on from a post-mortem document or something. You have to be there. You have to keep your eyes and ears open. You have to document, you have to try things, you have to actively debug, and you need to see patterns. Often it takes you like 3, 5, 10 outages. All look very different on the surface until you realize there is something deep down in the system that causes all of them. And it's a fundamental thing that if we change that, if we fix that, we can prevent a whole class of outages. So it is ops to make ops go away. And it also serves a psychological function, because nobody likes the backseat driver that knows it all and tells the developers all the things that they have done, when the developers are the ones that are being on call, and you're just the consultant on the sidelines that knows better. So if you are with the dev team in the trenches and you share all of that pain, and you can build up much more credibility. Number 6, no heroes. Being a hero sounds great, but actually heroes tend to have a very short and painful life. You do not want to have heroes in your organization, and you don't want to promote heroism. Heroism is bad not only for the hero, for their work-life balance, for their personal development in terms of new skills and new approaches. They will always be in the firefighting mode and always trying to apply the same patterns and get deeper and deeper into the problem space, but not like exploring anything outwards. But it's also bad for the team, because it sets a precedent. If you celebrate people for like pulling all-nighters and weekend shifts to just get things fixed that shouldn't have been broken in the first place, then the issue is, why would anyone put in effort to prevent these things from happening? So what you should actually celebrate is the outages that never happened. We actually prevented something before it took place, where you mitigated a risk long term. And heroism is also bad for the system, because it leads to accumulating tech debt. Because like, if there isn't enough stuff to burn, how would you get a fire that you can fight? So there's no inherent incentive for the development team or the operators or anyone to have a better long-term sustainability. And whatever your SLA or SLOs are, the people come first. You don't like throw the team under the bus just to uphold the SLOs. If it's not possible within the usual working hours, sometimes a little bit more, sometimes a little bit less, but if you overload the teams continuously, you have the wrong SLO, you have the wrong system, you need to fix things, and you will miss your SLO for a while until you have done that. And the on-caller is not the superhero either that like fixes all of the things. They understand what's happening, they mitigate somehow, and then they root cause and understand what actually has caused this as much as possible. They document all of that, and they create bugs, and they follow up that these bugs actually get assigned and resolved. It's not that they have to do all of that themselves. It is a team sport. And so is the actual incident response. An on-caller should never be alone. There should always be an escalation path where they can pull other people in. If the on-caller gets paged during the day, like everybody else should flock around them and say, can I help? In a structured way. Don't just like volunteer to help and like try fixing things in the system without coordinating. That makes only things worse. And it is also true in the middle of the night. It's nothing worse that you get paged at 3 a.m., you're sleepy, you're not focused, and you get an alarm that everything is down and you have no idea what to do, and there's no one out there that can help you. Always have an escalation path. Makes also people much more willing to be on call. 7, automate yourself out of your current job. Doesn't mean that you lose your job, but actually if you keep doing the same tasks years and years on time, you're doing it wrong. Because either your system is successful and scales up, then there will be more and more of these tasks, and either you need to hire a lot of people, or you will drown. So you need to reduce that just to keep the amount of manual work manageable. And if your system is going flat or down, typically that product doesn't exist for very long. And automation scales much, much better than manual work. And a lot of people think about that in terms of efficiency, in terms of time savings, and these are relevant. But there is a much more important thing about automation. Automation is consistent. If you ask me to set up 10 clusters, one cluster every week, every cluster will be a little bit different because I forgot something, I ran into a problem, and I had to do some kind of hack to make it work. And then you end up with pets, not with cattle. Automation is the same thing over and over and over. And then you need to figure out where does the automation fail over, how can you fix that, and it documents the actual process, it codifies it. And removing the manual work will free up time for engineering so you can do more improvements on the system and more improvements on the operation. So it is a virtuous cycle. And if you don't do it, it becomes a vicious cycle where you have less and less time. And then eventually you will drown in manual, boring work. The last section is about change. They say change is constant, but also, did you know, that change is the #1 reason for outages. So Ben Sloss once joked that the easiest way to make Google reliable is to take away commit access for all of our developers from our monorepo. Almost all of the outages would go away. We just would have to manage a little bit of capacity and everything would be fine. But that would be very bad for the business. It's called local optimization. So what we actually want to do is we want to find the right reliability and velocity balance that the product needs. Reliability and velocity are not always at odds, but sometimes they are. The thing what we want to do is we want to minimize the risk that each individual change has by being prepared, by doing the right thing, by, for example, not testing in production in things that you could also test in dev. Of course, you should have experiments and incremental rollouts and so on and so forth, but don't just say, oh yeah, I have this new feature, put it globally out there, it'll be fine. Use GitOps. You treat your configuration as code, you put it in the repo, you roll out the committed state from the repo, nothing else. It's not that this odd engineer has changed some flags on their laptop and sent that to production. These are the worst outages to debug. Only deploy when there are people around that can fix it, which typically means don't deploy on Fridays when people are heading out into the weekend. However, Fridays can be different in different parts of the world, and there can be special Fridays. For example, the holidays here in the Western world, or summertime vacations, or big company-wide events. where you don't want to deploy. However, that is a duct tape over a more inherent problem. Actually, your deployments, your changes should be safe enough that you don't need these kinds of production freezes to make them manageable. However, we still haven't managed to do that. So if anybody knows how to do that, please come to me after the talk. Number 9, outages will happen. As I said, you need change. You need to always keep your software up to date. It can be something as simple as security updates. And every change has a risk. And that's okay. It's a trade-off. There is no perfect reliability. And even if there is, we don't want that because it comes at a cost to the business that doesn't make any sense. The goal is not to prevent these things, but to limit their cost and to make them that you can limit that cost by reducing the frequency, the probability that they will happen through better architecture, through better processes, through better infrastructure, and then also reduce the impact of each individual occurrence by reducing the blast radius. Hopefully you don't have a global outage. It just takes down one of your clusters. It just takes down some of your customers. And also the time to recovery. So it's important to mitigate first and root cause later. Don't try to get to the bottom of this while your users can't access the system or while you have a security vulnerability that is out there that people know about. Make it stop the bleeding, and then do the homework later. One of the most powerful tools here is to be able to roll back safely and quickly. You do a new release, happens automatically, you get an alert, system is broken. First thing you do, roll back. Does the problem go away? Wonderful. Something was wrong with the release. Let's analyze what it was before we roll out again. When you do have an incident, especially a bigger one, use written communication. Even if you are in the same room, even if you have a video conferencing thing, try to write down all the important stuff. It's great for other people that come into helping with the incident. They don't have to disrupt you to interview you, what are all the things that I need to know. And you might even forget important things. They can just read up on what happened so far by themselves. And also it makes writing the postmortem so much easier. There's so much you can learn from that if you actually remember to write it down in the heat of the battle. And also, organizational transparency is super helpful. A lot of people say, oh, Google is doing a monorepo, so we have to do a monorepo as well. The question is not if you want to do it, but why. I'm not saying that you need a monorepo, but the power of our monorepo at Google is every engineer has access to almost all of the code. And so whenever something breaks in some dependency, we can read the code that actually has caused this, and that makes debugging so much easier. It even makes fixing so much easier because you can just send the patch to that team and say, hey, why don't we fix that function? Here's the code to do that. Last but not least, no haunted graveyards. You probably all have seen cases where a comment says, do not touch this, very important code. These are the things that I always try to immediately delete because they are toxic. I call them booby traps for change because they basically are this kind of minefield that whenever you try to change something in a system, some of these things will blow up in your face. And it really hurts your productivity as a developer. It slows you down. It impacts the reliability. It's really, really terrible. And also, the system will need constant fixing because of all of these things. And then it becomes a haunted graveyard that no one wants to touch, no one wants to get near anymore. So do not accept neglect. Pick up after yourselves. If you see a code that is obviously broken, take a minute to clean it up. If you submit code, do not say, yeah, I will fix this later and then forget about it. Actually do it properly. If you don't have to do it right now, if you don't have the time right now to do it right, when will you have the time? And also, don't build complex systems. Every time I felt very smart and built an amazing thing, happened a few times, the people that had to deal with this further down months, years later, really hated me, and rightfully so. And more often than not, these people included my future self. So try to build simple systems. It's actually much harder than you think, but it's totally worth it. It means that you really need to understand the problem that you're solving and the consequences and side effects of your solution. So, let me sum up. I think like 4 key areas are first the relationships. It's not only about the technology, it's about the people. It's about working together, independent of what your role is, and putting the right organizational incentives in place to actually encourage that. It's about managing change. You can't keep doing what you're doing, whatever it is doing. Even if it's the best thing today, it might be wrong tomorrow or next year. So you have to have a culture of constant improvement, because if you don't change, you will get worse, and at some point you might reach a tipping point. And like managing these things is not about being a hero, it's about engineering, it's about like doing the thing that has the most impact further down the road to like actually free up time and brain to actually do the things that matter for the business. And one of these things is simplicity. Boring is beautiful. And with that, I conclude my talk. If you want to learn more about this, there are multiple books out there. You can actually read them for free online at this URL and lots of other things. Thank you so much.